Well, that's disappointing. But speaking of things that aren't disappointing, you guys ready for your exam on Thursday? So today is going to be. What was that?
Professor John, so do we have labs this week? Because I was kind of listening to the last lecture, and you told that we don't have labs this week.
So we have the end of last week's labs, which meant that we had labs yesterday. We do not have a new week of labs, meaning that like today there's no labs, tomorrow there's no labs, Thursday there's no lab, Friday there's no lab, the Monday after spring break there's no lab. But Wednesday of the week after spring break, we start in labs again.
Okay, thank you.
Does that make sense?
Yep.
Other scheduling questions? Okay, today's going to be kind of a hodgepodgey day. That's why it's listed on the schedule as being hodgepodgey. The goal of today is to catch up on the things that we missed out on. In the case of this semester, we had a snow day on one of our previous Solidworks days, which means that we're not as far in Solidworks as I want us to be. So we're going to take about the first 20 to 25 minutes to talk about the rest of our Solidworks material, at which point we will talk about the last homework for Solidworks as well as the Solidworks project. That's the plan for the time being. Did you guys do well on the Rocket 2 homework assignment? Do you feel confident in your understanding of assemblies?
There was one problem with slits. I didn't know how to do it, and my friends didn't know how to do it either.
So you're referring to the fact that on the slits where the fin interfaces with the rocket fuselage, like from the top perspective, you had a cutout section like this.
Yeah.
And then the fin has a section like this.
Yeah, and make like no. Yeah, so here, remember like the rocket main part?
Yes.
They have like 4 slits.
Correct.
So it's like a linear, not linear, circular extrusion.
Yes, the outside section of the fuselage is round, but the back of the fin is square. Right?
Right.
Is that causing the confusion?
So it's not linear pattern, right?
It would be a circular pattern.
So I mean circular.
So if you mated one fin to the fuselage, which by the way, what I'm expecting to see is there to be contact between this point and this edge of the fin, not this point and the edge. You don't want the fin to actually be inside the fuselage. You want to be touching with a little bit of a gap on either side, because the back of the fin was square and the outside of the fuselage was round. So in reality, you probably have to fill that with adhesive of some sort, or maybe a weld, or maybe you make the back edge of the fin actually round. But you know, it's homework, and homework doesn't have to make sense. Was that your question?
Yeah.
Did I actually answer your question, or did I just assume a question and answer that?
So actually, like, okay, so we have main part. So remember we have like slits for wings,
Yes.
for rocket wings, for 4 rocket wings.
Yes.
And like I didn't know how to do it, so I just did through all. So I have main parts and have.
Oh, so your question is how to cut those?
Yeah.
I see. Okay, so the question was, hey, those cutouts on the fuselage, how do you cut those? So the answer to that question can be approached in a couple of different directions. One way to approach it would be to draw a rectangle on some sort of top perspective. Like, for example, let's say the fuselage looked like this, and we had mid-plane extrusion of, I don't know, 400. That seems about right. Okay, so one way to approach this would be to create a plane on which to draw from the top perspective and then cut a rectangular cutout. For example, if you were to sketch from the bottom, you could create a single cutout like this, where you specified the distance between the center of the cutout and the bottom of the cutout, whatever that distance was. You specified the width of the cutout, and then you cut in the upward direction. Now, in this case, I'm cutting from the bottom, which means that I have some amount of material left over. So if you were to approach it like this, you would either have to go back in and create another extrusion to fill in the bottom part, which you could do from the side. Like, for example, we could draw on the bottom again. Let's go with this perspective here. We were to draw another sketch on the bottom, and then extrude up a certain amount, we could fill in what we wanted to fill and leave only the cutout in the bottom section. That's probably the most simple way to frame that logic in your head. In my opinion, the more elegant solution would be to create a reference plane. Either you create a reference plane on a top parallel plane, so you could do something like, let's go with a reference plane relative to the top or bottom, and we say it's offset maybe 100 millimeters like this, wherever that actual cutout was located. You'd have to align it with either the top or the bottom. And now we could create a sketch on that plane. That was our rectangular cutout. In this case, I already have that drawn, so I could just move this sketch plane to plane 1 like this. And now I have the rectangular cutout drawn on that new reference plane, and I could create a cutout in that direction like this. And I end up with the slot for the fin. Another way to approach this would be to create a reference plane that was tangent to the edge of the fuselage. So if I create a new reference plane, I tell it that I want it to be tangent to the surface of the cylindrical section, and then I tell it that I want it to be parallel to either the front or the right plane. Then I end up with something that looks like this. If I want parallel to draw on the front, now I have a plane that I can actually draw the cutout from the front perspective like this. Now I just draw the cutout shape, something like this, and then I cut in some amount of material like this, and I end up with my cutout. That was like 3 ways to approach this. And then once you have the cutout, you can create a circular pattern. In this case, I'm going around that fuselage, so I could click the cylindrical part of the fuselage, and then say I want 4 copies of this to be equally spaced, and the feature I want to pattern is the cut itself, and now I've got 4 cuts. Did that answer your question?
Yeah.
Or did I again assume a question and answer that?
No. I just spent like 1 hour to solve this puzzle, and like you solved it like in 2 minutes. Yeah.
I also have been doing this a lot longer than you have. So after you've been drawing in SolidWorks for 4 years, I expect you to be faster, but it's a learning process.
Okay, so I thought that was...
Other questions on the homework? Okie doke. Well, the theme of today is going to be drawings. So we are going to talk about how to insert parts into drawings, and to do that, we're going to be opening up a new drawing. Like we had talked about on the end of last week's class, if you approach this using the general drawing format, like this, what you end up with is a template that doesn't really make sense for the context of the type of homework that we're going to be using. So in reality, every company that you work for is going to have their own template. You're not actually going to be using any of these general templates. No one uses these general templates. The logic of these general templates is just so that you have some idea on how to create templates. You can go in, start with one of these templates, modify it to meet your purposes, and save it as a new template. That's the logic. You don't need, for your homework assignment in this class, to have someone draw and then sign off on the drawing and then get approval from the manufacturing process and specify a material and specify a finish and specify who the welder is and specify who the machinist is and define a part number and relate this to some assembly for some larger product that you're selling. We don't need any of that, so it's irrelevant to have it on the template. So what we use instead is a template for this specific homework assignment for this class. And we went through that installation process in class last week, so I expect you all to have installed that by now. Do you all have that installed by now? Would you like me to talk through it again? Okay, so if you go into Tools and then Options, and you go up to System Options, and then you mosey on down to File Locations, you can see where SolidWorks expects files to be. The one that's relevant here is the folder for document templates. So our goal is going to be to download the files from D2L. Those files are located under Content, and then you go find the SolidWorks template files. And I have included the 2 files that you need to download. Those are called ME212 and A Landscape ME212 respectively. I have a set of installation instructions, so in case you missed last week's class and you missed this week's class and you can't go back and watch the YouTube video for some reason, if you want to have another way of walking you through how to install these, you can follow along with those instructions. I also have included 3 examples of the proper way to dimension things for this class if you want to see examples of dimensioned things. Also, all 5 of your homeworks so far have been using drawings that I created in Solidworks, and as a result, the drawings that you're going to be creating are going to look very similar to those. You can follow along with those images from those homework assignments and get a pretty good idea of what things you should be dimensioning. Do not go into drawings with the intention of dimensioning literally everything that you are able to, because remember, over-dimensioning is just as bad as under-dimensioning. Anyway, so now I download these 2 files. I try to convince my potato to download them, and I have the 2 files. They are now currently located in my downloads folder. Now I need to navigate to this folder location. So I want to go to C, Program Data, SolidWorks, SolidWorks 2018, Templates. The way that I go there is by opening up a file explorer, going to my C drive, and then going into Program Data. Program Data is a hidden directory. The way that you get there is either by enabling showing hidden directories, which you do by going into View, Options, and then View and Show Hidden Files, Folders, and Drives. Now I can see all the hidden directories. One of them is Program Data, and I go into that folder. Or you could just type C:/Program Data. Either way, you get to the Program Data directory. The next level is going to be SolidWorks, so I find the one called SolidWorks. And behold, it's SolidWorks. Now I go into SolidWorks 2018, and then Templates, and I place my files into this location. Once you place the files into this location, you can restart SolidWorks, which you do by closing out of SolidWorks and reopening it, at which point, when you go up into New File, and you click the Advanced button, congratulations, you have leveled up to the Advanced level. Under Advanced, we show all of the built-in templates. So in this case, there are the 3 that we've been using so far. And now a 4th. It's called ME212. As a side note, if I may pull a Zach Gutzmer, as an aside here, if you wanted to, you could create file templates that included features. Like if you found yourself working at a facility where you were constantly making rocket fins, you could create a default rocket fin, save that as a template, and then create a new rocket fin by just opening up that template. Then make whatever modifications you want to and save it as a new file. That way you don't have to start from scratch every time. That also avoids the issue of copying and pasting a file, at which point SolidWorks begins to go, wait, what are you talking about? Are you talking about the first file, or are you talking about the new one? I don't understand the references that you're making. Much like teaching a class, I don't get the references you people make with your bottle flip games and your Fortnite and your whatnot. The advantage of the templates is that you create something new that doesn't have any references and you save it as a new file. Make sense? Okay. Now then, we are creating a new drawing. It's called ME212. So we click on the ME212 template, we click OK, and what we get is a very simple template. It's on an 8.5 by 11 sheet of paper. It's in landscape. It has only the relevant information for us here, which is the date that it was created, the class, the name of the part, and your student name. Now, assuming for the moment that your name is something other than student name, you will have to change that to whatever your name is before you submit the file. We'll talk about how to do that in a second. Just like with assemblies, when you open up a drawing file, it'll prompt you through, hey, do you want to insert a part? You can also insert an assembly through the same logic here, but the file insert interface is already open. It's prompting us to insert something. So let's go find something, maybe the Rocket 2 homework assignment. Let's say I wanted to create a drawing for the fin from that Rocket 2 homework assignment. So I navigate to where I had stored that part file. I click on Open, and then just like with assemblies, SolidWorks is expecting my next click to be placing the part in the drawing. The first time I click, I'm inserting a base view. That is the view against which all of the other projections will be built. So if I click on the bottom left-ish part of my paper, that will allow me to create a top view and a right view. Once you click the first time, the subsequent clicks will be generating additional views. For example, if I wanted a left view, I just drag my cursor to the left and click again. If I want a bottom view, I drag my cursor down and I click again. If I want a right view, I drag my cursor to the right, I click again. If I want a top view, I drag my cursor up, I click again. In addition to those 4, we also have the ability to generate isometric views by dragging off diagonally. So the most common one that you've seen so far has been an isometric view from the top right perspective, which I generate by going up and to the right. Generally speaking, when you're creating drawings, you only need to create enough views to give the person who's trying to read your drawing enough perspective on what your part actually looks like. But the general rule is to create a base view, and then a top view, and then a right view, and then an isometric view. This 4 model view is very common, and in fact has its own special button within Solidworks to generate. Now, with these 3 additional views created, I can exit out of the Insert View interface by clicking Escape or clicking on the check mark. Now I have my 4 views. I can click and drag them to a new position on the page. You'll notice that the side and top views reposition themselves to maintain their alignment with my base view. My isometric view, however, doesn't need to be placed anywhere specifically. I could drag that over here, I could drag that over here, though that might be confusing, or I could place it against the top and right views. Once we have these views, we can change a couple of the things about the way that they're shown. For example, a common method to showing what the 3-dimensional object looks like is to show a hidden line on your part. That's the sort of thing that isn't relevant on this particular part. In fact, the only thing that you would be able to see with hidden lines shown is the back little notch of the fin from the right perspective. But the way that you switch your view style is by clicking on a view, going over here to the left, scrolling down, and clicking one of the other display styles. So for example, if I wanted to switch from hidden lines removed, which is the default, to hidden lines visible, which is the one immediately to the left, I could click on that one immediately to the left. This shows the hidden lines on my base view and all of the views that are referencing the base view. So that switched the isometric view, the top view, and the right view to showing hidden lines. I can also switch for one of the child views. So for example, if I wanted the isometric view to, instead of using its parent style, if I wanted it to be shaded with edges shown like this, it might make more sense to only do that on the child view as opposed to on the parent view and all of its children, if that logic makes sense. Questions so far? Okay, next order of business, now that we have a view place, let's change our student name. The way that you change your student name is by double-clicking on student name. You are now editing the template. Then you click on that field. Now you are editing that field. And now we type in whatever we want. That looks nice. Let me try clicking again. Don't you love it when a plan comes to... Oh, it did change. Ah, yes. My name is Dafda. No, let's try something a little bit more reasonable. Let's go with my actual name. And apparently it doesn't edit until I click OK. There we go. So if you go into editing your name and it doesn't immediately show you the letters that you're typing, don't be alarmed. That's apparently to be expected sometimes, especially when you're live streaming to YouTube and the computer can't handle both things at once. Now then, once you have your name, for the purpose of this class, you can leave the part title as your part file name. If you've been following the file naming scheme parameters that I've outlined in the homework assignments, then you should have the correct thing in there anyway. You could also go in here and change individual parts of the template by right-clicking on the sheet format and changing the template, but I would encourage you not to do it. Just change your student name, don't worry about the rest of it. If you really want it to show like 2 days before the homework is due instead of the homework due date, in an effort to try to convince me that you didn't procrastinate to the last minute, that's fine. Anyway, now we have our student name. We have the 3 views that we want to actually dimension. We have an isometric view to give someone some perspective on the thing that we're trying to indicate with the drawing. We are good to go. Now all I need to do is add some dimensions. The way that you add dimensions to your drawing is the same way that you add dimensions to sketches when you are creating a part or an assembly. You go up into the sketch tab here, you click on Smart Dimension, and then you add dimensions to whatever you want. So for example, if I wanted to indicate the height of this drawing, I could click on the top and bottom of this notch that's sticking out the side of my fin. I can click to indicate that dimension. I could click on this radius, drag that off to the right. I could add in a height of this fin like this. I could add in a width of this fin like this. That seems like a good starting point. Maybe I'll add in another dimension up here to indicate how far from the top that fin is supposed to start. And just for fun, I might add another dimension to indicate the total edge against the rocket fuselage. That's how you define dimensions. It is a very straightforward. If you have been creating dimensions in sketches, you probably already have the knack for it. The only thing that might be different is if you want to show more decimal places, like for example, if one of these was 7/8 of an inch and you wanted to show 4 decimal places instead of the default 2, you can either change the default number of decimal places, which will update everything that you've dimensioned, or you can change the number of decimal places in one specific dimension. If you click on it and you change the precision from 2 decimal places here to 4, for example, we show 4 decimal places. In addition to the dimension, you can also create notes. So if you go into annotation here, you can create a note like if you wanted to add a label to your view, like front view. That's not how you spell view. We could create another note up here that said maybe side view. So if you can see the yellow lines appearing on the projector, those are trying to help me align my notes with one another. Maybe side view. And really, to be consistent here, I'll add one more note on the top view. Top view. Similarly to notes, you can add balloons. Balloons are added for callouts. If you wanted to say something like, hey, this particular notch right here, don't make that round. You could add in a balloon that said 1, and then you could add a note over on the side that said balloon 1 is indicating the corner that needs to be specifically affixed to the rocket. Or you could say something like, hey, this notch needs to be able to actually nest inside the fuselage and should not have any wiggle room at all. You could make those call outs by using a balloon. The balloon is also really useful for creating notes on assemblies to indicate a bill of materials. So for example, you might create an assembly like a rocket, and you might say you have to have 4 fins, 1 fuselage, and 1 nozzle, and 1 nose cap piece thing. That is something that you would indicate with balloons, and then identification of the individual parts by a note that is based relative to the number on the balloon. There's also a button that generates bill of materials, but that's a little outside the scope of this class. The reason that we're not going into more about bills of materials is because according to most of the companies that we've talked to, they don't want you to generate them using the built-in Solidworks tools. Most companies have an inventory management system that generates a bill of materials based on part numbers and actual warehouse information, and not just what's in your assembly. Does that logic make sense? Okay, one more thing I want to mention on drawings here. I guess 2 more things, really. In some cases, the default scale that it tries to guess that will be appropriate for your drawing may not be right. The way that you change the scale is by clicking on the view and changing the scale for that view. So, for example, you could change this view to having a, 1 to 5 scale, at which point all of the child views will also change. You can also change the scale of the entire drawing, which will change everything on the drawing. Okay. Now, I said 2 things. So the actual last thing that I want to mention here, he said trying to get his view back. Stand by. Aha! So the actual last thing that I want to mention here is something called ordinal dimensioning. That's not something that appears very often in the sorts of assignments that I ask you to do, but if you are working in an environment where you often create drawings that have arrays of features, like for example, if you had a block piece that had a whole bunch of holes, maybe something like this, I don't know, you work at Lego or something, and you wanted to indicate the dimension of all of those circles relative to some data point, like you wanted to say, the center of this hole is 1 inch away from the left side, and the center of this hole is 2 inches away from the left side, and the center of this hole over here is 3 inches away from the left side, and so on. If you have a repeated dimension and you're referencing a single data point, once you get past 3 or 4 dimensions shown, it gets a little bit too complex to keep track of easily, and it can you can busy up your dimensions, and instead it might make more sense to use a style of dimensioning called ordinal or ordinate dimensioning. In that case, you would define a datum point, and everything would be dimensioned relative to that datum point. Like you would say 1, 2, 3, 4 to indicate that this is 1 distance away from the datum point. This is 2 distance away from the datum point. Does that logic make sense? So if it ever becomes something that's useful to you, the way that you indicate ordinate dimensioning is by clicking on the arrow that's below smart dimension, clicking on ordinate dimensioning, and then clicking on a datum point like this, and then everything that you click after that will be indicated relative to that datum point. This is like the worst drawing to try to indicate with ordinate dimensioning, but you get the gist. Questions on dimensions and drawings? Okay. When you submit your homework assignments, I ask you to save as a SolidWorks drawing file. I also ask you to save it as a PDF. So if you have the new version of SolidWorks, you can save this directly as a PDF. You don't need to try to print it to a PDF or anything. You can just save it as a PDF. One thing that I will make you aware of, though, when you are generating a PDF from a drawing, if you want a good-looking PDF that you can zoom in on, you have to increase the quality of your lines. You can add additional resolution to those curves and lines, and then you end up with something that is a little prettier to zoom in on. So, for example, you may have noticed that, like homework 2, I had no additional resolution to the drawings that were in your homework assignment, so when you zoomed in, it just got really pixely, as opposed to actually showing you in more information. This is the correct way to do that. Okay. So, your homework assignment for drawings is going to be to create drawings from your previous homework assignments. So I ask you to create a drawing from your donut, from your rook, from your bishop, from your gear, and then from something else that you've modeled. It can be from any of your choose your own adventure parts. All I ask is that the drawing be generated off of a part that you have submitted to a Dropbox at some point. So the good news is, if you've been keeping up with the homework, you shouldn't have to model any new parts for the homework assignment this week. All you have to do is create drawings. Now, because of the snow day, this homework assignment is assigned today and due the week after spring break, which means it's due on March 12th. I would encourage you to just get it done this week so you don't have to think about it when you come back. Make sense? And again, for each of these 5 parts, I want a SolidWorks drawing file. I also want a PDF. So if you have 5 parts and 2 files per part, that should be 10 total files that you're submitting to the Dropbox. Okay. Similarly, I'm also assigning a project this week. The project will be your midterm assessment for SolidWorks. So again, the midterm exam that you have on Thursday is to test your understanding of MATLAB for the first half of the semester. The equivalent grade for SolidWorks will be a SolidWorks project. This SolidWorks project is due the 29th of March. That's 3 weeks after spring break. So you are here, 26th, next week is spring break, and then you have 3 whole weeks after spring break to do the project. That's not a mind game. I'm not trying to imply that it's actually going to take 3 weeks worth of work to create something good for the project. I just want you to have the time in case you need it. There's going to be new Excel homework that starts the week after SolidWorks, the week after spring break, after we finish SolidWorks. There's going to be MATLAB homework that's assigned as usual. You probably also have, I don't know, when's your second statics test? Is that going to be like the week after spring break? So if you wanted to study for that and spend some time after the statics test, recuperating from the statics test, and you would rather work on the SolidWorks project the week after that, I wanted to give you the flexibility to work around scheduling issues that you already have. It is not a mind game. So your project is to make a fan. It's intentionally vague. I want to allow you the ability to create any fan that you want. If you want to make a centrifugal blower fan, if you want to make a box fan, if you want to make a pedestal fan, if you want to make a Dyson impeller fan, if you want to make a 120 millimeter case fan for a computer, if you want to make a big ceiling fan, I don't care. I just want it to be a fan. anything within the sphere of a fan is totally fine. Within that, your specifications are as follows. You are to create at least 5 unique parts, 1 assembly, a drawing for each of your 5 parts and assembly, a JPEG of each of your 5 parts and assembly, a PDF for each of your 5 drawings for your 5 parts and your drawing for your assembly, and on top of those, I also want an essay. Bear with me. The essay is only 250 words. That's not many words. And the essay is you, the student, talking to me, the person grading your assignment. It doesn't need to be formal. You don't have to cite references. All I ask is that you explain to me what you made and why. That way, I can have some context behind the thing that you designed and how you went about trying to design it. I don't expect there to be a table of contents. I don't want there to be it doesn't have to be a header and footer. It could just be like one long paragraph full of one long run-on sentence that was just you explaining to me why you made the thing you made. It is not a writing assignment so much as it is me just trying to understand your train of thought. Make sense? Okay. Yes?
Could it be like a hand fan?
So I want it to be a mechanical fan. So if it was a hand fan that was operated by like a 4-bar linkage that was rotated by a motor, that would be fine. But if it was just a hand fan that you would operate like geisha style, that's not what I'm looking for. The logic here is to create an engineering device, not an aesthetic device. Yes?
Okay, so you just want us to like, say, make something that looks like a fan, or do you want like all the gears and belts and motors to be like?
No. So within the context of the hypothetical situation for which you are creating the project, you are creating a model of a fan that is to teach students what a fan is. So I expect it to be functional in as far as the model sitting on the desk that I could show to people would be functional. So I expect the rotor to be attached to a hub that can actually rotate, but it doesn't need to be like an actual aggressive profile. It doesn't need to be powered by a motor. It doesn't have to include any of the mechanical components required to operate the fan. It just needs to be a model of a fan, if that distinction makes sense. So something that you could 3D print and set on your desk and talk about the features of the fan. Not something that you would actually manufacture. If you want to, you are welcome to model the motor and the fan assembly and all the fasteners that you could actually use to build the thing. That would be fine. On that subject, those base limitations, so 5 parts, 1 assembly, those are defining the bare minimum expectations. If you make the simplest fan with literally just 5 parts and your fan blades are just like a rectangle, that would be fine as far as the minimum requirements are concerned. And if you did them all well, you would get a C. That is the minimum acceptable level. Anything that you do beyond that, if you make something that actually behaves like a real fan, that actually has a realistic curve or fan blade profile, if you make something that has more than 5 parts, if you make an assembly that actually makes sense, if you make a cohesive design, those are the things that distinguish a C from a B and a B from an A. So 5 parts is the minimum expectation. It is not the recommended number of parts. Does that make sense? Okay. Questions about the project? Yes?
Can we model a fan, or do you want us to create like our own?
Up to you. If you want to model an existing fan, you can create a realistic model of a fan. If you want to imagine a hypothetical fan and create that, also fine. If you do model a real fan, I would appreciate it if you include a picture of it in your essay so that I can see what the real thing looks like. I should also point out that when I'm grading it, I'm not going to be the type of person that went, you modeled an actual fan, so I'm going to grade you against how accurately you're modeling the actual fan. If this is 150 millimeters, that looks like the actual fan is 148, I'm not going to deduct the point. But I would like to know that you actually are referencing something. Other questions? On a completely unrelated note, I want to show you guys something. Are you guys familiar with something called GrabCAD? So GrabCAD is a community that was created to try to simplify the process of creating common parts. So if you were an engineer working somewhere where you needed like a 120 millimeter M5 bolt, and you didn't want to create a model of a 120 millimeter M5 bolt, and you figure that someone out there on the internet created some at some point, you would probably look in GrabCAD. So you could look for bolt designs and see if they had a 120 millimeter M5 bolt. So you, as an engineer, would create some common parts and upload them, and then other people that needed those common parts could grab them from GrabCAD. GrabCAD started as a central repository of common parts, and it's kind of shifted over the last couple of years into like an educational resource. So people have created homework assignments and projects that were required to be uploaded to GrabCAD as part of their requirements. We're not doing that for the scope of this class, but I want to point out, like, if you are trying to learn how to do something and you're curious, hey, how would you model a bolt in SolidWorks? You could type in bolt. You could specify that you're looking for specifically things that were modeled in SolidWorks. You could click on SolidWorks, and then you could download a SolidWorks part. You could download it. You could reverse engineer how they went about making the features that created the bolt, and you could learn from it. So under bolt, we have a whole bunch of example bolts. If we were to type in like engine, we could see a variety of different engine designs, and we could open them up and try to reverse engineer how they created that model. If you type in fan, for example, you get a whole bunch of different fan designs. So the very first time that I assigned a SolidWorks project, I made it intentionally open. I said, model something. I don't care what you model, just don't model anything that's the same as your peers. So I created a little dibs chart. It was like, my name's Joseph, and I'm modeling an Xbox 360 controller. And then the person below them was like, I'm modeling an airsoft rifle. And the person below them was like, I'm modeling my Ford F-150, and so on and so forth. And about 25% of the submissions that we got that semester were from the internet. They were plagiarized. Don't do that. It's not worth it. It's going to be tempting. You could submit something that someone else did and do no work. Trust me when I say it's not worth having to retake the class. And that's the best case scenario. Okay. Do you have any questions? Yes?
Why in GrabCAD as a weapon, which is like likely to be illegal because it's like a killer weapon? Like, did you see it? Like, because legit, it was so detailed.
A weapon?
Yeah. So do not constant strike. Like,
We can do that.
Yeah, like
but like
you can download 3D printable parts to make a firearm if you want to.
yeah, but
Like that's available on the internet.
yeah, but like I mean, legit, like simple people like who are not engineers can like download it and like build in their phones. It's like
Yeah.
like using 3D printer, but
There-
it's not supposed to be illegal, right?
There are a lot of things that are illegal on the internet.
No, but like
I'm just saying.
there's a literally like like not for hunting like weapon for us. It's just literally to like take people like one by one like it's like.
Can I have your attention back for a couple more minutes? Is there anything that you would like to know how to do in SolidWorks that we didn't cover in these last 5 weeks?
To make a fan blade.
Use a loft. What was that? So creating a curved surface could be approached in a couple of different ways. One way would be to create a curved profile and sweep it. So something like if you were to draw on the right plane, I could create what is arguably the worst fan blade design ever. Are you ready? Here we go. Something like this. And then create an additional sketch that was maybe on the top plane and consisted of a line and a curve, so something like this. You could sweep it. So you could create something that looks like this. That is not a great aerodynamic design. This is not a good fan blade. It is, however, a decent looking fan blade. For the purposes of this class, if you came up with an interface to attach this to a center hub, that's just fine. If you want a slightly more complicated answer, the better way to model would be to approach it by using a loft. We talked about it for like 4 minutes. That's outside what I'm actually expecting people to do. But if you want a technical answer, that would be the best way to model a fan blade. Other questions? Anything else that you would like to know how to model in SolidWorks that you do not yet know how to model? Okay, cool. Well, we will dismiss here. Good luck on your midterm on Thursday.